Hello everybody and welcome back to Juno, where we are currently working on getting some of these career missions done. So we're not, looks like, going orbital just yet. This is going to be, well, a lot of interesting things here. I'm not sure about getting to the top of the peak and bringing a camera with us. Apparently this is supposed to be done via a car. Okay. Well, this isn't timed, so we need to work on timed missions. This can no longer be accepted after 30 days, as can this. So we need to be grounded for more than 10 seconds, go faster than 27.8 meters per second. Noted. Okay, so we're going to accept this, and we're going to get ourselves a new vehicle here. So let's get going on that. I want a completely new craft. And how do we rotate this? Okay, something like that, I guess. That seems fine. And then we would put in a fuel tank here, I guess, as a structural part. Indeed. So we're going to put in a fuel tank, not in this orientation. How do we switch the actual orientation of this? Okay, let's just go to a new craft here. There's probably a way to do this in here. I believe we were told how to do this at some point. I've definitely forgotten. Excellent. So let's see. This is the camera options here. I want to be creating a horizontal car, right? So that is what I'm looking to do here. We're currently very vertical. No doubt about that. I mean, we can grab this guy and we can rotate it like this, but that doesn't, I think, do what we want it to do. There's definitely a way to do this. The tutorial did it for me previously, I'm pretty sure. So let's see here. This is just various staging. That's fine. Okay. Well, I guess we can just do it this way. So we can grab this guy, and we can just rotate it, like so. And we'll just have to, I guess, manually rotate this. This is almost certainly not the correct way to do this, but we'll figure it out. Okay. So we attach it something like that. Okay, that looks reasonably fine. Then we wanted to put our wheels in here, so it's not under propulsion. What is it under? Here we go. Control and descent. So we've got car wheels, and they have a built-in electric motor. Okay, so we're going to want to downsize the size on this a little bit, I suspect. But let's put this guy right here, and let's bring the size of this on down a bit. Cool. Something a little bit more like that. Now, these car wheels should probably be actually attached. That would likely help. I think this is a little long as well. Let's have it be about, like, 1 meter long. It probably doesn't need to be very long. I want this to be quite cheap, in theory, and now we're going to need to mirror this. So we're going to need to go in here and set this to, I guess, radial symmetry, but this is probably not what we want. This is going to be mirrored across the mirror plane, and that's not what I wanted. Can we Control Z? Yes, we can. Cool. Okay, so that sounds good. We can mirror the left side of the craft to the other side. The main problem with this is assuming that it's in rocket orientation, and it is not. So there's that. Well, we could simply duplicate it and do it without using symmetry, but I don't like that plan, to be honest. So I'm not going to do that. Instead, we're just going to select this part, and I'm going to do it in radial symmetry, but this is probably going to break directionality if I had to guess. Yeah, I'm pretty sure it will. So in the back here, I want to go into the part properties. Here we go. And I don't want to have this turn. I want the torque to go up probably. And the gear ratio will probably need to go a little bit higher. We're probably going to need a fair amount of torque to get up this mountain. So we can bring this up to something like, we can maximize the torque, and we can bring the gear ratio up to, like, maybe around 4. we can see what that ends up looking like. In the front here, I don't really necessarily want this. Well, we can have it turn at like 20 degrees. That'll be fine. Yeah, we can see that they're definitely turning together. That's the directionality. Okay, so how do we invert the turning? Because that's going to be an issue. Well, I think we're better off just building this straight up in a vehicle assembly, right? Instead of in a rocket assembly. That would be the better way to go. I'm sure we could figure that out somewhere. So what is this? This is crew, this is design info, and this is edit program. Yeah. So this is the view options, this is search parts, staging editor, symmetry tool. I would think that what we need to do is flip the orientation of this. And I'm pretty sure it taught me how to do this, but I can't remember. I'm going to look it up. I'll be right back. Okay, I did not actually solve that. I'll get there eventually, but what I did do was I broke the symmetry here, and it should be set up correctly-ish. Steering might be inverted. We'll find out. Let's put this out on the pad, and we should probably put this on the village runway, I think. I'm not entirely certain that we're going to be able to break the speed record here. We'll find out. So our deadline is 60 days, right? First question, turning. Okay, so we're going this way, right? That would make sense. Okay, so turning is not inverted, and we can accelerate nicely. Okay. So now the question is, how much speed can we actually get? So we're going to go down here, we're going to be grounded, and we're building up as much speed as possible. We're currently going at about 16 meters per second, 17, 18, 19. We have to get to 27.8. I don't know that we're going to do that, but that's fine for right now. This is just a quick test at this moment. So we're going to get to 22, 23. This is close. We're reaching the end of the runway here, though. So let's not break this. Let's just revert this back. So I want to end flight, and I want to recover this craft. Okay, so that gives us at least most of our money back. I think all of it, actually. So now we're going to hop back in here, and I want to make a couple of modifications. Specifically, I want to turn up, I think, the torque in these front wheels, but let's keep the gear ratio a little bit on the lower side for now. I want to see what that ends up doing. So let's try that. That'll give us a higher RPM, but lower torque for having that gear ratio the way it is. So that should be relatively fine. Now let's just move this on out. And this will probably let us go faster than 27.8 meters per second, is my guess, at least downhill. Okay, so we're going 15, 16, 17, 18, 19, 20. I don't know if we're going to reach it, actually. 27.8 is not a huge amount of speed, don't get me wrong, but we're just a little shy of it. Okay, so I raised the torque or rather the gear ratio in the back wheels, and that was because we were thinking about going up the mountain, but we probably shouldn't do that yet. We should probably have a bespoke car for that, and we should probably lower this gear ratio down. So lower values result in less torque, but higher max RPM. So let's lower this guy down to like a gear ratio of 1, and let's see what that actually does to our top speed. Now, our acceleration is probably going to be far lower, but our top speed should be higher. The question is, can we reach the top speed before we get to the bottom of this runway, right? That is certainly an interesting question. We definitely have a whole lot less torque here. That's for sure. But let's just start accelerating here. So we're currently at about 10 meters per second. We're going to get a lot of gravity assistance from this. We have to remain grounded for 10 seconds. So we also can't like, go down the mountain, right? But there we go. That's definitely enough speed. We have to hold it for 5 seconds. 4 and 5. We're braking, and we're good. Okay, so we're going to end that flight and recover the craft. Perfect. So that seems wonderful. Next up, we've got this endurance trip. So this means that we have to stay grounded and drive around 5 kilometers. Okay. That's definitely a thing that we can do. But we may want to grab this guy first. Go faster than 1 kilometer per second at 80 kilometers at sea level. Okay. We definitely know how to do that. Let's accept this one. I just kind of want to alternate between these timed ones, I think. So we're going to hop in here now. And that means that we're going to need to... Do we have a saved craft? No, we don't. There are stock crafts, but I'm not, I think, going to utilize any stock crafts. We're going to create a new craft, and this is not needing to be like that, but we're going to add in a fuel tank. So this is going to be a stage 2 here, and I'm wondering right now... So we would need a solid motor, I think. We want to have this be as cheap as possible. This is not going to need to be this big. So let's have this be about this size for now. Much smaller payload. We're going to want to have a nose cone up on top of it. That'll do for now. Let's put in an interstage about here. There we go. And then let's put in a fuel tank. And I'd like to bring up the fuel tank in size a little bit to be something like this. That'll do. And then let's put in our 4 solid motors. I don't know about that positioning. Yeah, that positioning is not ideal. Let's put this in about here. And then we'll go into symmetry mode and we'll do 4x symmetry. That seems decent. And then we're going to put in some fins as well. So this should get us up over 1 kilometer per second, and this is a little too big for the fin. I think we'll go something like that, and then we'll just drop this down to be about here. There we go. We'll go into symmetry and do... quad is probably fine. 3 would probably be enough as well. This should complete that mission, I think. This is going to cost us about 8,000 to launch this. Let's check what our delta V is here. I mean, 3.16 kilometers per second, that's fine. Starting thrust to weight is 4.78. That's a lot of thrust to weight. Okay, this is going to get going fast. And that's probably okay as long as this heat shield doesn't break. Okay, I'm actually going to save this craft, and we'll save this as our 1 KMS. Okay, that's fine. And let's exit the designer here. And I want to take a look at what the actual contract parameters here are. So we need to reach 80 kilometers, go faster than 1 kilometer per second, and we have to do it in 60 days. Okay, that seems very easy. So these are our milestones, and that's our exploration. Okay, yeah, understood. So our real goal is probably to fill out all of this, but for now, let's do this light speed mission, and let's get this over with. So we're going to put this 1 KMS out on the pad. It might be an ambitious title, but I'm pretty sure this will get to 1 kilometer per second and be high enough up. So we're going to want to lift this off, and we're going to want to set our heading to be not quite as aggressive as we did previously. Maybe somewhere around 60-ish degrees, I'm thinking. But what's our staging? I should probably check that. There should be an interstage here. Yeah, I'm interested in knowing what our staging is here. Well, we'll revert it back if it's broken. I want to keep the heading where it's at. Thank you very much. 90 degrees. Okay. And let's launch this and see what happens. Okay. This is very, very rapid off the pad. No doubt about that. Let's bring this over to somewhere around 60 degrees. There we go. And we'll start trying to make our way over there. This first stage has propelled us up pretty far. But let's see what the second stage gets us. Okay. And we are trying to turn over this direction, although it's not great. We're not being very successful at it, to be honest, and this might be due to a lack of fins here, or perhaps due to a lack of gyroscope in this, but we don't actually have to go horizontally. We just have to be going fast enough, which our orbital velocity is high enough. We just now need the altitude. Okay, so we just need to coast from here. And then we don't even have to crash. We can just abandon this, in theory. But we are going to crash, almost certainly. Okay, that is 80 kilometers, and that is high enough. So we can end this flight, actually. We could try to recover the craft, but it cannot be recovered because it's not on the ground. Yeah, go ahead and destroy it. That's actually 100% fine. It's going to get destroyed anyway. Okay, let's see what is next. Drew Orbit. Okay, so Drew is the... Yeah, Drew is our origin planet. Okay, sounds good. So we need to have a periapsis of greater than 80 kilometers, so we need to actually orbit this. Sure, there's no timing on that. There is a tutorial for it. I don't know that we're going to take it. I feel like we are good enough on that. So this is just drive around for 5 kilometers. We'll accept this, and let's hop back into here. And let's create ourselves a new craft. And the real question is, if we selected this, maybe it's in the properties of this. Configuration rocket. Ah, okay. So rocket or plane? Yeah, we're going to have a plane configuration here. That is what I was looking for previously. That sounds good. Now, we're going to put on a fuel tank, and this is going to be considerably smaller than this, for sure. It does not need to be anywhere near that size. We'll keep it at like 1 meter in length, thereabouts. Okay, and now what I want to do is I want to put some wheels on. Okay, we'll put in a wheel here. I alt-clicked that. So used to Kerbal. Okay, there we go. And we're going to have this guy here be duplicated, of course, in mirror symmetry. Both of these will be. There we go. That'll do for now. And then at this moment, we're not too interested in like torque or anything like that. This is probably fine as long as these front wheels turn. The question is, are they turning in the correct direction? Maybe. But even if they're inverted, it doesn't really matter. We just have to stay grounded for 5 kilometers, right? That's the mission here. So we would put this on the runway. And we need to stay grounded for 3, 2... I want to keep our pitch where it's at, thanks. And we need to drive around for 5 kilometers. Oh, right. I did not set these to activate based on the... Let's recover that. I did not set those to activate based on the pitch. They're activated based on throttle right now, so we need to change that. So we need to come in here, select this. We need to have our turn input is fine here, but the RPM input should be on pitch for both of these. Okay, so something like that. That should be fine, assuming they're both going the same direction. They are, but I think they're both inverted. Yeah, this is the way we want them to go. So that should be fine. We'll put this out on the runway again. And now we just need to drive around for 5 kilometers. Oh, we completed Tier 2 of launched crafts by exceeding 15. Cool. Oh, this is actually backwards from what I expected it to be. No, it isn't. We're just facing the other direction. Okay, so we need to drive around for 5 kilometers. I think that we just head out over this way. We're up to about... Okay, this is going to be a little bit. Sure. So this is like 150 meters at this point. I don't think... Hang on, that's the wrong button. Okay, chase view. There we go. I don't think that we wanted to take that turn at that speed, so we'll just bring this back over here. I'm wondering if this resets if we get air. If not, we can just go up and down the runway, and that seems reasonably fine. Maybe we'd break a speed record, too. I highly doubt that, for the record. Okay. Well, that was exciting. That was very exciting. We're flipped over right now, so everything is going to be inverted. But this did not actually reset. So that's good to know. As long as we're aware that this is all inverted, that should be absolutely fine. So this is about 10%. Oh, that's a lot of speed in terms of the turn. So this is about 10% of the distance that we needed to go. The question I have right now is, if we go down to the end of this runway, how much does that get us? It should be like half a kilometer or something like that. Okay, let's brake. I don't want to actually jump here. So we have gone a kilometer here. Right, we're inverted. Okay, we have gone a kilometer. We are not accelerating. We're accelerating this direction, which is not the way I intended to be going. Okay, that's interesting. Let's bump our throttle to full for right now. And perhaps we just lack the torque to go uphill at all? Or perhaps we're out of electric charge. We don't appear to be going at this moment. So I'm wondering if there is a limit of electric charge. 0.00 watt hours? I bet you that's what it is. Okay, so in that case, we're going to need to recover this, and we're going to need to put in some sort of power generation. Okay, so that's fine. This is a camera. We might not actually have the tech for it. Let's head out of the designer for right now, and let's go into the tech tree and see what we can get here. Okay, so static electricity would give us access to a battery, a command disk battery, and a battery pack. I don't think that's really what we want, though. Although ultimately, coming down to Racer might not be a bad thing for some of these contracts. But for the moment, I'm wondering about something like solar panels. In KSP, we would definitely have the ability to have solar panels by now. Okay, that's all rocket engine stuff there. Interesting. If we head back in here, this is the electronics category. But that isn't necessarily the electricity category, the power category. What is this? That's a structural panel? Okay. Goblin solid rocket motor. That's a Druid. Small landing gear. I don't think that we currently have anything to generate electricity. So, we have to find something to generate electricity. I went back into the build. Well, that was unfortunate. We want to go into the tech tree. So what do we have that we can use to generate electricity? We've got mechanical engineers here. That'll give us access to, like, struts, blocks, and balls. Okay. That's not actually going to take me back. Okay, there we go. Crew limit and chair. Again, not really what I'm looking for. Bird wannabe gives us access to wings and such. Static electricity is probably the path that we want to go down. This will give us thin film, solar panels, and fuel cells. Okay. So we could definitely grab static electricity and then rapid charge, which would give us access to some form of electrical generation. From there, we can go in here. And we can now get a solar panel. So we would want to put this, like, right on top here, but I would like it to be, like, a little higher up. I don't suppose that, well, we have battery tanks. It's a little large, but, I mean, I guess it'll do. I do want to rotate it, though. Yeah, more like that. And I want this part to be, no, not connected in like this. I want it to be connected in like this. I want to essentially use it as an elevation. Well, I guess this could work. It could be something kind of like this, but we would need to massively reduce the size of it. I'm not able to grab it here. There we go. Now we're able to. Cool. So we would drop the size of this down considerably. Yeah, something more akin to this. And then I would like to rotate it to go not like that, but like that, but also, I guess, that. These are some awkward rotations here. Okay. Let's attach it like this. And then grab this whole assembly. And rotate the assembly like that. And try to assign that a position kind of like this. I don't know that this will be great. But, I mean, it'll give us some power anyway. Let's put that out on the pad. But I kind of want to widen where our wheels are. I feel like our wheels are too close together, and we're going to be prone to tipping. So, to that end, I would like to expand out this guy a little bit. Like so. And then get these wheels updated. This out over here, I think is... No, that is correct. We just need to drop these wheels down to here. Okay. No, this isn't correct. Specifically, what we need is this to be brought up in size. Kind of like that, but now it's too much. That's interesting. Okay, so I guess we would do something kind of like that. But it's too big. So we're going to bump it down in size, I guess, and we'll have it be about, like, this? Sure. Then we would attach these guys here and these guys here. It's a little bigger. We're just looking for distance here, right? So that looks absolutely fine. We'll put this out on the runway. And we need to go 5 kilometers now. Okay. So let's get moving here. My main question at this point is, how are we doing on our electric charge? We can see that we are at 100%. If we accelerate up here, we are remaining at 100% charge. That looks ideal. Now, we're not going to get quite as much speed as we did previously. That's not a bad thing. We're just going to need to get ourselves a fair amount of distance here. We're quite stable, actually. So that's noted. And now the question is, can we make it back up the runway once we make it down the runway? Well, I'm slowing us down a bit. Ooh, okay. That didn't go well. So, air is bad. Noted. Well, we're going to recover that. This is 4.6K, so even though it fell apart, none of the parts have actually been destroyed. So we just lost $100 from that. That's not bad. So we're just going to have to be a little bit more careful with it, but we can definitely do that. Now, it is time to put a cut in here, so I'm going to go ahead and do that. And next episode, we're going to get this contract completed, and then we're probably... Well, we can make a choice at that point. This one is timed, the others are not. So that seems okay. You can leave your offerings to the engagement gods in the form of likes, comments, subscribes, and bell ringings, and a very special thank you to all of the channel members for making this video possible, including ALS Gamer, Atala, Ali Lee, Dark Horse, Xenocyte, Upper Cumberland Gamers, Nick Smarty, Dimitri H, Punching the Microphone, The Lounge STL, Kentogan, and all the rest. And of course, you. Thank you for watching. If you'd like to support the channel, you can click the join button down below the video, and as always, I will see you all next time.